Um, Good day. You are welcome to another episode of our lecture. Today we are going to look at what electrolysis is all about. It's a very important aspect of chemistry. It has really played a lot of role in our industry, in so many aspects of our life. Electrochemistry will look at the pioneer of electrochemistry, major pioneer of this aspect of chemistry is Michael Faraday. Uh, he is the major pioneer. You cannot discuss electrolysis, electrochemistry without mentioning great scientists like Michael Faraday. What we are going to do is, what is electrolysis? Electrolysis is simply the generation of electricity or electric current as a result of chemical reactions. That is generation of electricity or electric current as a result of a chemical reaction. Or you can also say electrolysis can also be defined as the initiation of chemical reaction as a result of passage of electric current through an electrolyte. Here you generate electricity as a result of passage of electric current, or you initiate chemical reaction as a result of or you generate electricity as a result of a chemical reaction. The chemical reaction taking place generates the electricity for you. Or you initiate a chemical reaction as a result of the passage of an electric current through what is known as an electrolyte. Now, what is an electrolyte? We are going to look at some terms. There's no way you discuss electrolysis without knowing some terms. We'll just pick some of those terms, and the first term we are going to look at is electrolyte. What is electrolyte? Electrolyte can simply be defined as liquid conductor of electricity. Liquid conductor of electricity or electric current. Liquid conductor of electricity or electric current. We have our electrode too. What is an electrode? Electrode can simply be defined as solid conductor of electricity. Solid conductor of electricity. And we have this solid conductor. We have two types of solid conductors. We have the anode and the cathode. The anode is the positive conductor of electricity, while the cathode is the negative conductor of an electric current. Now, there are other terms, that is the anion and the cation. What is the anion? Anions are ions that migrate to the anode during electrolysis. Since the anode is positive, during electrolysis, the ion that can easily migrate, that will move to the anode, must be a negative ion. And you refer to that ion as an anion. Whereas those that migrate to the cathode, which is the negative electrode, are known as the cation. Examples of cations are metals like metallic ions like sodium. The moment sodium loses an electron, it becomes sodium loses an electron, minus electron. This is positive. It becomes sodium ion. This sodium ion, all metallic ions are referred to as the cations because during electrolysis in solution, they migrate to the cathode. They are positive, they migrate to the cathode, so they are called cations. And during electrolysis, the negative ions, let's look at chlorine. Chloride, when it loses, it becomes chloride ion. It becomes chloride will gain an electron to become chloride ion. This chloride ion is negatively charged. In solution, it's negatively charged. And since it is negatively charged, it will migrate to the positive electrode. And therefore, it is referred to as anion. It migrates to the anode. So such ions, the negative ions that migrate to the positive electrode are referred to as anion. An example is chloride ion. An example of anions, an example of cations are sodium ion. These are some of the things that makes up electrochemistry. And in our subsequent lecture, we are going to look at Faraday's law of electrolysis. We have the first and the second law of electrolysis. We can also quickly take the Faraday's first law of electrolysis. The Faraday's first law of electrolysis states that the quantity of substance deposited at the electrode during electrolysis is directly proportional to the current passing into the electrolyte. That is the amount of substances deposited at the electrode, either at the anode or at the electrode, depends on the amount of current passing through, it is directly proportional. The amount of substances deposited is directly proportional. The higher the current, the higher the quantity of substance you obtain at the various electrodes, that is the anode or the cathode. In our subsequent lecture, we are going to look at factors that affect discharge of discharge at the electrodes. We are going to look at those factors, either the type of electrode involved or the position of the ions in what is known as electrochemical series table. We hope when next we meet, we'll do justice. We'll even look at some of the calculations involved in determining the amount of substances deposited at the electrode. Thank you for listening. Looking forward to your subscribing into our channel for more of these lectures. Thank you.